Now it's time to learn when the different phases of the moon rise and set. And this is a nice skill to have. You can reach the point where you can go out at night, glance up at the sky, and you may have them memorized by this point, but you may have to figure them out a little bit. But you can get quick at figuring them out. You can see the moon in the sky, identify the phase, and know when that phase rose. And say you're out in the middle of a camping trip, you could tell by the appearance of the moon about what time it happens to be, the appearance of the moon and where it happens to be in the sky. We have some big ideas so far. Among them, as the Earth rotates on its axis, your local horizon rotates with it. You rotate with it, and your local horizon just depends on where you happen to be on the Earth, so it rotates with the Earth. The half of the universe above your horizon is visible, potentially. Half of the universe below your horizon is not visible because you'd have to look through the Earth to be able to see it. Now, some important things. As your eastern horizon sweeps past something, that object rises. And I put rises in quotation marks because it doesn't actually do anything. It's your view is changing because of you having moved, and now you can see that thing. You could also say an object rises when your eastern horizon sweeps past it. Maybe we should say appears to rise instead of rises. As your western horizon sweeps past something, that object sets, or that object appears to set. It's the rotation of the Earth that makes things appear to rise and set. You've seen pictures like this before. We're going to simplify the picture before too long, get rid of the person, just make the Earth as a blue dot, but for now we'll go with it a little bit just for reminding things. Here's a person standing on the Earth. The Earth will turn counterclockwise from this viewpoint. The eastern horizon points out forever into space to the left, and the western points out forever into space to the right. When they're at this location, this would be where a person would be standing at 6 a.m. Their eastern horizon is pointing at the rising sun. Those yellow arrows up there represent light from the sun, which is a long, long ways away. Now, as the Earth turns, that person turns with it, and their eastern and western horizon also turns with it. Now they'd be at the point where they have the sun directly overhead. We call that 1200 hours. I think today I'm going to stick with the 24-hour clock and just call sunrise happened at 600 hours, noon is 1200 hours, and just go with that. And you can see the AM PM conversions there, but I'm going to drop them after a while too. Okay, another quarter turn. We get around to 1800 hours. Now the western horizon of this person on there is sweeping past the sun at this time. That would be when the sun sets. This person is on the equator, by the way. We're not going to try and mix latitude into this. We'll keep it simple. Another quarter turn, 0 hours, and the person is facing directly away from the sun, or they have the entire Earth between them and the sun. That's midnight. One more quarter turn, and they're back to 6 a.m. Their eastern horizon is sweeping past the sun again, and the sun is rising for them. We could fill in more hours on here, and here I put a couple more tick marks on here. You could fill in even more. You could have one at 300 hours, 900 hours, 1500 hours, and 2100 hours. We've got them all worked into there now. If we tried to put in 100 and 200 hours and all the intervening ones, we'd get too crowded here, so we'll just stick with these. Right now the person is standing on Earth at about the 2100 hour mark. This person is standing on the Earth at the 1200 hour mark. They'd be experiencing noon. And they're standing on the Earth at the 300 hour mark. After this, I'm going to drop the sketch of the person and just have the green arrow with the E and the W on the ends of it. Oh, one more. Okay, they're standing on the Earth experiencing 1800 hours. Now we've taken it a little farther. We've backed off of the Earth even more. We've got our sort of clock circle surrounding the Earth. This is a clock circle that goes counterclockwise. And we've got phases of the moon labeled there. So we'll work forward from here. And we're just going to replace that complicated looking Earth drawing with a blue circle because I didn't want to try to have that complicated thing rotate. We've got enough to deal with right now. When does a waning gibbous moon rise? Okay, look at where the waning gibbous moon happens to be. And in the past, I've had students that don't quite get over a hurdle of realizing that an object rises when your eastern horizon points at it. A waning gibbous moon does not rise at 300 hours. 300 is when it is highest in the sky. And so it can't have risen then because that's when it's overhead or at its highest point in the sky. So when does it rise? It rises when the eastern horizon points at it. So let's bring a horizon in here. The point where that horizon, that green arrow, is just touching the blue earth is where a person would be standing. Here it's at the location where they'd be experiencing 600 hours, sunrise, but we need to rotate it until the eastern horizon points at that waning gibbous moon. There we are, and they'd be experiencing about 2100 hours, or maybe a little earlier, 2000 hours. About 2100 hours is fine. That would be about 9 p.m. or maybe a little bit earlier. When does a waning gibbous moon set? Well, to set, that western horizon has to point at it. So we rotate the Earth a little farther until the W points there. And now we've got something that's probably about 900 hours. Close enough, or we could call that 9 a.m. If you want to convert these to AM and PM, that's okay. When does a first quarter moon rise? Well, again, I would have people pick the wrong time. It does not rise at 1800 hours. 1800 is when the first quarter moon is highest in the sky. 1800 is about sunset. The first quarter moon is highest in the sky right at sunset. Okay, well, when does that first quarter moon rise? Our eastern horizon has to point at it. Let's rotate the Earth. There's the eastern horizon pointing at the first quarter moon. Just where it touches the Earth there, that green arrow, the person would be standing at the 1200 hours mark. The first quarter moon rises at noon. You could make up a poem about that, although it's almost the only one that rhymes. When does the first quarter moon set? You can probably kind of pick it off of here after you've watched a couple of these, or maybe done it yourself. It sets when the W points at it at that first quarter moon, which happens at about 0 hours, just about midnight. The first quarter moon rises at noon and sets at midnight. Those are 12 hours apart. In fact, something you'll see is that these are all going to be 12 hours apart. Now, that's for an observer at the equator. If you're far north or south of the equator, as we are, you get some time variation built into it, but the 12 hours up is going to be just fine for what we're doing here. We'll try one more. When does a waning crescent moon rise? Well, it does not rise at 900 hours. You know that by now. That's when it's highest in the sky. So when does the eastern horizon point at it? Spin that green arrow around the Earth again as the Earth rotates. And you'll see that it rises about 300 hours. Okay, It rises about 300 hours. It's highest overhead at 900 hours, so it takes about 6 hours from rising to when it's at its highest point in the southern sky. Then it starts to sink down as it approaches the western horizon. When does that waning crescent moon set? At 1500 hours, 12 hours after it rose at 3. Now, what if you don't have that diagram handy? If you are, say, taking a test and you're not given that diagram, do you have to memorize those rising and setting times? No, you don't. And I'll show you why. I should also make a confession here. I really dislike memorizing things. And so probably one of the reasons I went into physics is because I didn't have to memorize things. I can remember processes, but I have a hard time just remembering little snippets of things, or maybe it's something my brain just doesn't like to do. So I'll show you how you can figure out those rising and setting times. The microphone may get louder because I'm moving to right in front of it. So here I've got a blank sheet of white paper, and this happens to be a large sheet of paper, 11 by 17, but that's so it'll be easier to see. And you can do this on a 9 by or 8.5 by 11 sheet of paper just as well. So here's the deal. First thing I do on this piece of paper is draw arrows for the direction from which the sunlight comes. The sun, which is what makes those arrows, the light, is way off there to the left somewhere. In fact, if the Earth is here in the middle, the Earth or the sun is 93 million miles or 150 million kilometers in that direction. But I'll just put a little E here to stand for the Earth. And then I'm going to put a bunch of moons around here. And I'm just going to do 4 of them for now. And I'll have on here what are called the quarter phases, which are new, first quarter, and I'm just going to abbreviate that, first Q, full, and third quarter. And then coming off of the Earth, I can usually remember these, but I'm going to put little marks coming off here anyway. Put an arrow here and call this 600 hours. Put an arrow in this direction and call it 1200 hours. An arrow in this direction and 1800 hours, and then an arrow in this direction, and this will be 0 hours. And I'm narrating this as I'm going, but you might want to practice making a diagram like this, and I'll show you some things you can fill in on it a little later to help yourself out. But let's figure out, when does the new moon rise? And all I do is I take my pen and think of it as this end is my eastern horizon, this end is my western horizon, and the Earth rotates toward the east. So I'd rotate it this way, and I imagine this is the horizon of a person who's standing right there on the 6 o'clock part of the Earth right now. So the eastern horizon points that way, the western horizon points that way, and it rises at 6 a.m. So I'll put an R here, 600 hours for when it rises. When does it set? Well, the Earth has to rotate until the western horizon, that end of the pin, has to point at it. When is the person there? 1800 hours. So sets 1800. And if I wanted to know the rising and setting time of any moon, I could put it where it is on the diagram. Like say it's a very thin third quarter moon. Well, that might put it here or something like that. And so I'd rotate this thing around and I'd be pointing in that direction, and I'd think, just short of 6, maybe 5 a.m., something like that. But let me figure out these other quarter cycles first, and then we can kind of go from there. When does the first quarter moon rise? Well, rotate the Earth until the eastern horizon is pointing at it. That's the eastern horizon end of the pen. Oh, the person would be standing where they are at 12 noon. So this one rises at 1200, and it's going to set, get that in the right orientation, rotate the Earth a little farther until the western horizon is sweeping past it. Okay, right there at 0 hours. So we've got that one. The full moon, when does it rise? Well, let's see. I have to have that horizon end pointing at it, so I rotate the Earth until that points at it. And that's when the full moon rises. The person would be standing here experiencing 1800 hours. So it rises at 1800. The full moon rises at sunset. It's in the sky opposite the sun. So that kind of makes sense. All right, when does it set? Have the Earth rotate here. Eastern horizon points at the sun. The western horizon is sweeping past that now full moon, and they're standing at the 6 o'clock part. So it sets at 600 hours. And then the third quarter moon, when does it rise? Point our eastern horizon at it. And where is the person experiencing then? They're experiencing 0 hours. So this one rises at 0 hours. Okay. By the way, in between the full moon and the third quarter moon, the moon will rise by about 50 minutes or 52 minutes later every day. It takes about a week to get from here to there. Usually about 3 nights after the full moon, the moon will be coming up, 2.5 hours or so after sunset. It's plenty dark then, and so 3 days after the full moon is a good time to go out stargazing with a telescope. You can see faint things. The moon actually interferes with being able to see things because it lights up the sky so much. But a few nights after the full moon, it's not a problem anymore. Okay, when does that third quarter moon set? Well, rotate this thing around, and you'd be experiencing the setting of the third quarter moon at 1200 hours, noon. Those are the 4 major ones. You can fill in the in-between ones. For instance, the waning gibbous moon, which is what it happens to be about now, at least in the middle of the waning gibbous part, it would rise halfway between 1800 hours and 0 hours, just moving along there, which would be about 2100 hours. Okay, and it would set, let's see, well, you can point your thing at it there. Sets about 9 in the morning, 900 hours like that. And you could fill in places partway between those too if you wanted to, and partway between any of these others. I was talking all the way through doing this process. You can do it a lot faster if you're not talking, at least as far as you don't have to fill in all these times. You just have to start with the arrows, have the Earth in the middle, and make part of the clock. And the important thing is you have to remember that 1200 hours points at the sun. That's where a person is at noon. And 0 hours, midnight, points away from the sun. They're on the side of the Earth away from the sun. So that's a way you can do it by hand quickly. You can also remind yourself of all sorts of things with a diagram like this. You can put from here all the way around to here, you can write waxing, because the portion of the moon that you see night by night is growing larger for this entire half the cycle. Then you can go from here all the way around to here and write waning for that entire half of the cycle. The portion of the moon that you see night to night is growing smaller, or the illuminated portion you see is. And you can put gibbous in here from full down to first quarter. You can put gibbous up here from full quarter down to third quarter. Now remember, it's a waning gibbous in here because it's waning for this entire top half of it. I missed. Stop there, and then you can put crescent here and crescent there, and you can fill in all sorts of things about the moon on a diagram like this, and you can do it in just a couple of minutes, and you have lots of things that'll help you with the test. But you have to know what you're doing and practice that a little bit. See if you can do it. That fills in rising and setting time for lunar phases.